Hello everyone. Today we will be discussing questions on kinetic theory and the gas laws. Let us attempt some few of these questions. By what amount must the temperature of 200 cm³ of nitrogen at 27 degrees centigrade be increased to double the pressure if the final volume is 150 cm³? Assume ideality. This is a typical gas law calculation. To know which of the gas laws to employ, you have to bring out the parameters provided. It was given that the initial volume V1 is 200 cm³, and the final volume V2 was provided as 150 cm³. If the initial pressure P1 is P, the final pressure P2 will be 2P. How? The question says, by what amount must the temperature of 200 cm³ of nitrogen at 27 degrees centigrade be increased to double the pressure? Double of P is 2P. Initial temperature T1 is 27 degrees centigrade. Remember, it should be converted to Kelvin by addition of 273. 300 Kelvin. The final temperature is unknown. From these provided parameters, the perfect gas law to use is the general gas law, which states P1 V1 divided by T1 is P2 V2 divided by T2. This implies P times 200 divided by 300 is equal to 2P times 150 divided by the unknown. Let's try and make T2 the subject of the formula. This will give us 2P times 150 times 300 divided by P times 200. P will trash out the other P and T2 will be 300 times 300 divided by 200. This will be equal to 450 Kelvin. Converting that to degrees centigrade, you have 450 minus 273. This is 177 degrees centigrade. Though there is 177 degrees centigrade in your options, but this is the wrong answer. How? This is the final temperature T2. The question asks, by what amount must the temperature 27 degrees centigrade be increased? So this implies change in T, which is T2 minus T1. 177 minus 27 is 150 degrees centigrade. A is the correct answer. Let us go further and solve some more questions. The combustion of carbon 2 oxide in oxygen can be represented by the equation 2CO plus O2 to U2CO2. Calculate the volume of the resulting mixture at the end of the reaction if 50 cm³ of carbon 2 oxide was exploded in 100 cm³ of oxygen. Since we are discussing volumes, this is Gay-Lussac's law. 2 volume of carbon 2 oxide reacts with 1 volume of oxygen to yield 2 volume of carbon 4 oxide. This is ratio 2:1:2. At the starting of the reaction, 50 cm³ of carbon monoxide will react with 100 cm³ of oxygen. Here, there is no product yet. At the end of the reaction, all of carbon 2 oxide have reacted away. Oxygen has used just ratio 1 compared to 2 of carbon 2 oxide. 50 divided by 2 is 25 cm³. The same ratio of carbon 4 oxide was produced as that of carbon 2 oxide used. This is 50 cm³. The question said, calculate the volume of the resulting mixture at the end of the reaction. Therefore, O2 remains 100 minus 25, which is 75 cm³. CO2 formed is 50 cm³. Therefore, resulting mixture has a volume of 75 plus 50, which is 125 cm³. The correct answer is B.